Hello, I'm Sujata from CBSE NEET JEE Chemistry.in. In this video, we will learn how to apply the reaction between esters and Grignard reagent to produce an appropriate tertiary alcohol. You will see this question and its variations in many exams, and understanding this will give you a definite advantage. How is 4-phenyl heptan 4-ol? This is 4-phenyl heptan 4-ol, 7 carbon atoms, prepared from an appropriate ester and Grignard reagent. The first thing to be noted is that 4-phenyl heptan 4-ol is a tertiary alcohol. If you recollect the applications of Grignard reagent to prepare primary, secondary and tertiary alcohols, you know that a tertiary alcohol can be prepared by treating the Grignard reagent with a ketone. Now, tertiary alcohols can also be prepared from esters, right? Esters on reaction with Grignard reagent, suitable esters on reaction with Grignard reagent can also produce tertiary alcohols. So this session, or the series of questions going to be discussed here, will have a few questions on this kind of a transformation. Esters to tertiary alcohols, but a special ester will produce even a secondary alcohol. So those questions are going to be discussed here. Alright. So this is a tertiary alcohol. It has been specified that it has to be prepared from an appropriate ester, not a ketone. An ester is a derivative of carboxylic acid. Alright. Now, if you look at this, you have one of the components should have a phenyl group. The phenyl group could be present either on the Grignard reagent or on the ester, not on both, because we want only one phenyl group in the final product. Right? You remember the reaction with Grignard reagent will involve the formation of an adduct which is further hydrolyzed to give you the final product. So we should have only one phenyl group. It could be a part of the Grignard reagent or it could be part of the ester. But most often, phenyl esters are what are made to react with appropriate Grignard reagents. Okay, so let's start with a phenyl ester. We start with C6H5COOCH3, alright, plus CH3CH2CH2 MgBr, propyl magnesium bromide. The usual Grignard reagent reaction occurs O minus C plus because of the shift of this bond towards oxygen, and here we have a negative end here and a positive end here, and we get this adduct where the MgBr is bonded to oxygen and the CH2CH2CH3 is bonded to this positive carbon, to which already a phenyl and a methoxy group are attached. Right? If you look at this, if you subject this to hydrolysis, we will not get our final product, which is a tertiary alcohol. So what we have to do is remove a few groups from this adduct in order to create another ketone group, another carbonyl group. If you get a ketone now, the ketone can further react with a Grignard reagent to give you a tertiary alcohol. So complete transformation from an ester to a tertiary alcohol goes via the through a ketone also. So now we have got this adduct. Ester plus Grignard reagent gave you an adduct. Convert this adduct to a ketone. Why? Because you want a tertiary alcohol, right? So how do you get a ketone from this? Remove the MgBr and the OCH3 by these transformations. See, MgBr and OCH3 are lost. So what happens is OCH3 is lost as a negative charge. So we get MgBr OCH3. So this carbon loses the bond, but a new bond arises from here. This bond shifts towards this position. You will get C6H5, C double bond O, CH2, CH2, CH3. So now you have got a ketone, right? Now you react this ketone with a Grignard reagent, right? So that there are totally 7 carbon atoms in the final product. You already have 1, 2, 3, right? 4. You already have 4 carbon atoms in this ketone. So the Grignard reagent should have only 3 carbon atoms, which is why you react this ketone with propyl magnesium bromide. So you used a propyl magnesium bromide earlier. You're using one more molecule of propyl magnesium bromide. The usual Grignard reaction occurs. You first get the adduct OMGBr, and to this carbon CH2, CH2, CH3 gets attached. When subjected to hydrolysis, you get OH, you get the tertiary alcohol. This is what is required. See, CH3, CH2, CH2, COH, C6H5, CH2, CH2, CH3, which is 4-phenyl, 1, 2, 3, 4. 4-phenyl heptan 4-ol. This is the expected tertiary alcohol. This is how you convert an ester to a tertiary alcohol. We have over 230 videos with in-depth explanation of concepts in an easy and lucid manner in our organic chemistry course. Moreover, we have close to 400 videos of solutions to every kind of question that can be asked in any exam. Click the link in our description below to check out our course. Subscribe to our channel to regularly get new content to help you score high marks in chemistry.